Hi, this is Kian, back from a snowy few days in lovely Oslo, which was really a lot of fun. But I thought I'd just go ahead and sort of share the demo that I did, more or less, at the Forma Hackathon there, so that you can see some of the work that we've done inside Forma using our VASA WebAssembly implementation. I can explain a little bit more about what it's doing. Anyway, so this is a local extension. Actually, we're just using the local testing extension inside Forma to basically load our extension UI from a local web server. That's essentially how it works inside Forma when you want to do some testing. We haven't deployed this more widely, but when I click on the initialize VASA button, so it's using our sort of voxel-based architectural space analysis engine, so VASA, to it's loading that in from a WebAssembly package. So it was a C++ library that's been converted within Scripton to WebAssembly, and this is now executing it in the browser. It's voxelized the whole space. We can already turn on the voxels just to sort of see what they look like. These are the larger squares of voxels are actually plates of multiple voxels, of course. Anyway, there's some optimizations done there, of course, to minimize the memory usage. Anyway, so that's there's a voxelization process that has gone on. Then we have these various dots. So let's see here. We have was originally a little bit quirky inside the Forma UI. There wasn't this ability to interact directly with the canvas. So I kind of created these Etch-a-Sketch style controls. So somebody said they also look a little bit like a Nintendo video game controller, which I also think is very cool. So these are controls that would allow you to sort of specify the start and end points for the pathfinding, for example. But what I've also done here is to sort of allow you to double click. If you double click on there, you can then pick the point, and then what happens is that it's going to adjust the sliders so that you can then use the sliders from there, and it works relatively. So here, for example, I can do the same thing for the red dots. We can use that roundabout, and we can turn on the pathfinding. That's going to go ahead and enable pathfinding for this kind of particular configuration. We can go and use the sliders as we want to there. We can say, well, actually, let's double click and go inside here to see what that does. The other thing and then this is not new, but it is also kind of fun, is if we click, and it's totally hidden, right? If we click on the path text there, what it's actually going to do is to zoom in and then follow the path through space. So we're just modifying the Forma camera properties in order to essentially follow that path. Now you can see it's a little bit blurry, this line, which is the line you're following. That's just because of the resolution looking at the canvas. But let's go and zoom back out using Command F. So that's a bit about the pathfinding. We also have visibility analysis. So this is again not new. This was already there, and you may have seen it before. But it does apply in the same way as these dots here. Look at, you can see it's a pink dot underneath. But here, if we double click one of these sliders, then we can go and choose a spot inside here. For example, inside this building. This is a building that we've modeled inside there. Similarly, let's just double click and go maybe there. There we go. And you can see how that works. Of course, as you move the sliders around, you'll see, that changes, morphs, or the visibility changes as you move it around. We can also change the size of that dome, which will obviously make it harder to calculate each time, a little bit slower. We can, because sometimes, one thing we found was this kind of uniform coloring made it harder to see the shape of it. That's why we had this kind of darker in the inside. We make it darker the closer it is to the center of the visibility sphere. But then we also have enabled this ability to kind of dapple the outside, and it kind of goes through and changes the color of randomly of the various voxels that are on the outside of the shell. So it turns into this kind of quite cool cork-like effect that I have to admit is quite fun. I like it. But that's the visibility visualization aspect. The last one, and this is not the last one. The last one on this list is shadows, which we'll take a look at. So this is just using VASA to calculate shadows based on the sun directions. So we use visibility from a direction. There's a capability inside VASA to calculate shadows, and you kind of do the inverse calculation in order to calculate what the shadows should be, and then we're just showing them in this sort of translucent color. Of course, the sun doesn't move in a linear way like this. This is just actually what I did was to take the sun directions for June 21st 2023 from different times of day, and so this is going from early in the morning to late at night, or anyway, I forget exactly, maybe it's 8 till 10. I don't remember exactly the timings, but essentially we're taking them at 10-15 minute increments through the day in order to be able to, it's just a simplified test really. We could totally choose have much more elaborate UI to specify the times or the dates for other than that particular day. All right, so that's shadows. The thing that I went ahead and sort of worked on during the hackathon, other than the sort of location of points by picking, was this views from the building. So this came up as an area of interest, to be able to say, well, for any particular window in this building, we want to be able to look outwards and detect what it is that we're seeing inside that view from that window. So what we've done is, there's another capability inside VASA which is around visibility, a visibility cone from a point. So we've gone ahead and implemented that, but we've effectively created or done that analysis for every single window location around this particular building. Now the way we're doing it is that we take this building, and we're looking at the traversable voxels, which are the ones that are on top. We turn that on. These are traversable voxels that are on top of that building. And then we take sample points from around this area here, and then we have a set of sample points, and then we effectively transform them downwards to each of the floors. So we have forget exactly how many points we have that come out for the sample for this particular area, but then we have 10 different floors. Oh yeah, so there must be 24, because there are 10 different floors, and we have 240 points. So we have 24 sample points from the top, and then we transform them down, and then, because as you can see, it kind of goes in stripes, vertical stripes, because for each sample point on top, we create the sample points on each of the floors going down. Now, right now, we're not doing any particular intersection of these points. There we go, get around this side, with any geometry. You can see that they do get occluded by geometry. If we increase the size of this particular cone, then of course you can see it's clipping the surrounding geometry. But we could also create a voxel model of all the greenery if we have sort of 3D geometry for trees, etc. And then we could do an intersection with this visibility cone in order to determine how many how much of the greenery is visible from each window. So it's totally feasible to do that. It's just not something that I did during the course of the hackathon. All right, so that is pretty much everything that there is inside this particular demonstrator for VASA integrated into Forma. It's worth bearing in mind that while this is dependent on a WebAssembly package that isn't currently public, you can do exactly the same workflow using the Dynamo package, the VASA Dynamo package that's available in the via the Dynamo package manager, which you can integrate now with Forma or Revit or Civil 3D. So you could absolutely be using this workflow just using Dynamo instead of WebAssembly and web development tools. Okay, well, that's all I wanted to share with you today. Thank you for paying attention, and yeah, see you next time.